Okay, so we're doing Java 4 lesson 6 today, and we're doing searching methods. So first I'm going to start off with kind of like it's not really like a new concept necessarily, but like it's a wording for it. It's essentially called sequential searching, and it's essentially just a form of searching through an array or another kind of collection one by one until you find the value you're looking for. So I'm hoping that it doesn't sound too difficult, and it actually is not too difficult, because this is kind of what you would do if you didn't know about what we're going to learn today. It's essentially what you would just do normally. If I gave you a problem and I asked, okay, go find this value in this array, write a code for that, then you would probably do this already without like actually knowing about it, right? Like I'm pretty sure it should be pretty familiar, hopefully. Like even if you haven't done it before and I haven't given you a problem on it, I'm hoping that you would still know pretty much how to do it, even without me telling you. But yeah, that's typically looping through the array and then just looking at values. So for example, again, this should hopefully look pretty familiar or something like that. And again, you're just having the array, you're creating an array with a certain amount of values. You're going through this array, right? Remember that this is like an enhanced for loop, and we're going through every single element of the array. And we're saying if the I variable here, if any of the values are equal to 5, let's say, then what we're going to do, we're going to print out found, because we found the value we were looking for. And we're going to break out of the loop because we're done, right? We don't need to go on any further. So again, that should look pretty familiar. And this is essentially an example of sequential search, because like, again, we're looping through every single value, checking to see if each one is equal to the value we're trying to find. And if we found it, then we're just breaking out the loop. Again, the output would be found because there is a 5 value in here. So 5, 5, and so we print out found. Okay, that should hopefully be review, sort of review, I guess. Now we're gonna get to the actual part that like is difficult. Binary searching. Okay. So binary searching is a form of searching through a sorted array or collection, where you first locate the middle of the collection, then you compare the value you want to find with it. So important thing to note here is sorted array or collection, like it is italicized, because if you don't have one, if you have like a random array that you just entered and it's not sorted in like from least to greatest, then it's going to have some problems, because otherwise you can't really do this with accuracy. But yeah, if we just think about it, right, like binary, right? What does bi usually mean? Okay, well, we can turn this into a quiz question. What does bi usually mean? So like the prefix bi, what does it typically mean? Yeah, Jeffrey got it. Yeah, so binary, the bi part usually means 2. And that's exactly kind of what we want to think about, because binary is all about like splitting an array in half to look through. And thereby you're making everything a lot simpler, because you're cutting everything in half bit by bit to make it. So like it's essentially how you can remember it by. Yeah, so essentially how it works, kind of explanation of the process you go through, is if the middle of the collection, right, the middle value, if it's equal to the value we want to find, then the search is done, because we already found it, right? Like it's in the middle of the value, like we don't need to go anymore. But typically that's not the case. And what we have to do then is, if your value is greater than the middle, then the search essentially just blocks out the values that are lower than the middle for consideration and searches only the upper half of the collection. So with this kind of searching, you can easily eliminate like half of the values you need to search through. And that means you don't need to search through every single value like sequential searching, because know that now, like if we look at the middle, okay, if the value that we want to find is greater than the middle, then we automatically know that none of the values below the middle are ever going to be the value we want to find. So we don't ever need to look at that anymore. So this is the reason why having a sorted array or collection is so important, because otherwise, like, okay, well, when we look at the middle and we compare it with a value, okay, let's say that the value is greater than the middle, but then you could easily miss out on a value, the value that you wanted to find that was in the lower half, just because of the array not being sorted. So again, like, it really relies on the array being sorted or whatever you're searching. And then after, it just only searches the upper half of the collection. And there it finds the middle of that particular section of the array. And then it compares that middle value again with the value that we want to find. And essentially it goes on and so forth. So like, it finds the middle, it compares that middle value to the value we want to find, sees if it's either equal, greater than, or less than the middle, the value that is. Then we continuously block the part that we don't want to consider anymore of the array. And we continue doing that until essentially there is only like one value left that we need to check. So it goes on like this until it either finds the value, like at one point it finds that the middle is the actual value we want to find, or it just does not find it at all. And what that means by like do not find it at all is, for example, if there's only one value left for consideration because we continuously shortened the amount of values we have to search through, then if there's only one value left for consideration and it is not the value we're trying to find, then that means we did not find the value. And we can just say, no, we did not find a value, we're done. That's kind of what I meant by that. Yeah, same thing if the value was listed in the middle, we would just go through the same process. So if if the value that we want to find is less than the middle, then we would just like make it so that we don't consider anything higher than the middle at all, and we just focus only on the lower half of the array. So again, like, it goes both ways. So like, depending on whether the value is less than the middle or greater than the middle, then we adjust accordingly. And of course, yeah, search can be programmed either through recursion, which is why it matters that we learned recursion last time, or regular while loops. So depending on what you want to do. Data collection can have duplicate values, so you can have like 2 5s, and then it would all, if you're finding value 5, it will still work, but that's being note. And of course, it might be difficult to visualize, so I have a bad drawing to show you guys. Okay. So firstly, we're doing ARR equals 13579, and the value we're trying to find is 2. So what happens is that, oh, that's supposed to say high. Anyways, that value right there is supposed to be high. Anyways, so essentially what we do is we create some values to start setting in like a threshold, like a boundary that we want to consider. And first, of course, we want to consider everything, right? So we first set the low boundary equal to 0. We set the high boundary equals to 4, which is essentially, if you look at here, like 1, 2, 3, 4, 5, there's 5 values in there. We're essentially doing the length of the array minus 1. So that's still considering all the array, all the elements in the array. And again, notice how like these numbers don't represent the values of the array. It represents the indices, so where it is at. Right, so the low boundary is 0, which is at the very beginning of the array. The 4 represents the 9, which is at the very end of the array. So make note of that. And also, we need to keep track of a mid value, right? Because we want to find the middle of the array and thereby like start comparing, right? So we have to have mid value as well. And how this is calculated is you do the low plus the high divided by 2. And essentially that's just the average of the 2. So that's how you find the middle value. So the middle in this case is 2 because 4 plus 0 divided by 2 is 2. So then we do array ARR mid. So we're seeing the value of the array, right? And we find that the array of the array element at the index 2 is 5, right? But then when we compare it to the value that we want to find, we see that 5 is greater than 2. which means then that we do not want to consider anything higher than 5, right? Because it's already greater than 5, but greater than the value we want to find, right? So why do we want to compare it? Why do we want to check the values over there? So therefore, what happens is that we have this now. So we have the 1, 3, 5, 7, 9, but essentially because we already checked 5 to see if it is equal to the value 2, and we saw that it was greater than 2, that means we just erase both 5 as well as the other values that are after it, because we don't need to compare them again. We already know, we either know that they're not going to be the value we're trying to find, or we already checked it in the case of the 5 value. So we don't need to check those again. I apologize. Okay, well, like that, you can see, like with this visual kind of thing, we see that like we already shortened the array spectrum like a lot, right? Like instead of having to search through 5 different values of the array, we essentially just like crossed out like 2 extra ones without comparing them. So this is like why binary search is really efficient and why it's really good for this. So now we only have to search through this, okay? And again, with this, we need to also reset our boundaries because, you know, like we can't just continuously use the high equals 4 one right now because we already like got rid of the 4th value, right? So we don't need to compare that. So we need to adjust it. So low is still equal to 0 because we never moved it, right? We're still considering the stuff that is below the mid. We're setting high is equal to 1 because that's the high value now. Mid again is equal to the low plus high divided by 2, which means it's 0 because 1 divided by 2 is 0 in terms of Java, because again, like integer notation, integer division. So mid is equal to 0. And then we again go through the same exact process. We see array ARR 0 is equal to 1. But then we see 1 is less than 2. So again, what this means is that we X out the 1 because we don't need to compare it again, right? We already know. And so we X out that. And now there's only one thing left in the array. And we move low is equal to 1 now because, again, we X'd out the value 1 here to be only here now. So low is equal to 1. High is still equal to 1 because we never changed that. Mid is equal to 1 because 1 plus 1 divided by 2 is equal to 1. And now, again, we're like checking again ARR mid, right? And there's only one value left. So what happens is that we see that 3 is automatically not equal to 2, which means it's not found. And again, that matches with what we're talking about, right? Because 2, if we just look at it, it's not in the array anymore. So this ends up coming to be pretty true, right? Because it's not found. And I guess like one thing to know is just like note how repetitive this is, right? Like we're doing the same thing. We're just finding a middle value. We're checking to see whether or not like it's the value that we found is equal to the value we want to find. We're seeing whether it's greater or lower than the middle, if it's greater or lower than the value we want to find. And we continuously move the boundaries back and forth, compare it again, and again, right? Like it's pretty repetitive, which is again why we usually do it in either a loop or we do it in a recursion method. All right, let's play a game. Yes, okay. Not now. Anyways, so we're gonna do a guessing number game because I think it's a really good analogy of what we do. And so I guess the question I want you guys to think about is like, what would be the best strategy to guess the number in as little tries as possible? So actually, no, I'm gonna ask it to you guys right now. Answer in the chat. What would be a good strategy to guess the number? So if, let's say we're guessing a number between 1 and 100, what would be a good strategy to make things as efficient as possible and guess in as little tries as possible? Just type in the chat. What do you think would be a good strategy? Forget about it. So yeah, the best strategy is indeed making it so that you're finding the middle, And then you're continuously comparing whether or not the middle is the value that we want. And so that is the best way, right? Because we're eliminating half of the answer choices already. And that makes things a lot quicker than if you tried to go one by one through the values. Because, okay, what if we're starting from 1 and then the value you're trying to find is like 100, right? Like, what if it's all the way up there, right? That's not the best way to do things. So I just wanted to have this thing too. All right, let's play a little game, or yeah, something like that. But yeah, so let's do that. Please guess a number, enter, and press guess. Okay, so let's try the sequential searching method, right? So, okay, I guess 1. Okay, it's greater than 1. Okay, 2. Do you want to see how long it takes? I feel like it's going to take a long time. Let's hope it's like on the lower end. Okay, anyways, you get the point. It's going to take a long time. Okay, I hope this reset it. Anyways, so what we want to do then is, right, if we're doing binary searching, which was what I was referring to, I was implying that we check the middle, which is 50. Oh, can you guys see the message? Wait. Oh, actually, yeah, I think you can see the message actually. Yeah, it says, well done, it took you 1 attempt. Okay, that wasn't supposed to happen. Anyways, let's try this again. So let's say 50, right? My number is less than 50. Okay, well then we're gonna automatically cut off anything after 50, right? Because that's not what we want to guess. So we do 25, let's say. Greater than 25, okay. Well, the next half number, right, is 37. It's greater than 37, okay, so it's between 38 and 49, right? And then we can do 45, let's say. Less than 45, okay, 42. Less than 42, so it's between 39 or 38 and 41. You can do 40, less than 40, and so it's 39. Actually, no, maybe not. Hey, well done, it took you 7 attempts. So again, I just wanted to play this game to like emphasize that, again, binary searching is efficient because of the fact that it's cutting everything in half. So even though it might be harder to program, it is a very efficient thing. And when you start programming with a lot larger programs, it's like even more crucial to make sure that your program is efficient as possible, because otherwise it might take you like a day to like actually run your program. So you usually want it to be as efficient as possible. Anyways, that was a fun detour. Okay, moving on. Another visualization tool. So I guess try entering different values and use the different sorts. So how do they differ? How do they search for their values? So keep that in mind as we go through it. So essentially, how do they differ? Anyways, so this is actually not something I found. It's something that I saw in a class, but yeah, so it's not my value. Anyways, ooh, interesting. Okay, let's say we were trying to find 965. And just so you know, these are like the blue numbers are the indice values, and the numbers here are the actual values of the array. So let's say I was trying to find 965, which is like all the way at the very end. I'm gonna turn the animation speed down. Okay, let's say we were trying to do linear search. And you can see that it's like checking every single one. I'm gonna speed it up a bit. You get the point, right? Like it's searching through every single one. And the thing is, right, what if we said, I wanted to find 1,000? What if we said we want to find 1,000, right? Then it's still going to go through every single element of the array, right? It's still going to go through every single one because it needs to make sure that all of them are not the value. So like imagine trying to find that. Anyways, meanwhile, if we try to find 965, but we did binary search, oops, that is too fast. If we try to find 965, which is the very last value, you can see we assign a low and a high. We find the middle, and we get to here. But then we find that it's not. Okay, it's going a bit too fast. But yeah, you can see like how like so quickly it is eliminating all of it. Hey, I found it. Okay. So you can see then like it's really fast, and you can see again we have the low variable to keep track of what the lower boundary is. We have the high variable which keeps track of the higher boundary, and we have the middle value which is keep track of what we want to compare. So that's again kind of the thing. But if we try, actually no, let's just for the sake of consistency, let's try 1,000, right? And it continued to compare. You can see it like very quickly finds that there's no value. Anyways, and then we have, if there's a larger one, right? What if there's a larger one? Well then, if we tried binary searching, then like very quickly it can finish searching all of this. Meanwhile, if we were trying to do linear search, of course this is going fast, but like imagine the amount of time you have to take to check every single one of these. And like not even this, if you had like an even larger array, then like there's no point, right? So it's just gonna take too long. So yeah, that was a very long explanation for why binary search is important. But again, like the important thing to know is that binary search is efficient, and the fact that like it always compares the middle value with the value it wants to find, and then continuously X's out a certain amount of values that don't fit. But yeah, try entering in different values and use different sorts in your own time if you want to. How do they differ? And how do they search for their values? And that's talking about the searching methods. Anyways, talking about all of this, I haven't actually talked about code. So yeah, this contains an example of how to implement binary search using both an iterative approach and a recursive approach. Because again, there's two ways of doing it. So iterative is looping, recursion is recursion. All right, so some notes here, right? So again, we have our array. That shouldn't be too big of a surprise. This value, this variable is talking about like what we want to find, right? So in this case, I want to find the value 5. I'm setting a low boundary again because I want the 0, the very first element, to be the low value at the very beginning. I want the high variable to be the array.length -1, which is the very last element. And I have a Boolean here just in case, like to keep track of whether or not we found the value or not. And I set it to false for now because we haven't found it yet. So this is the important part. So while low is less than or equal to high, then what I do, again, this is important because like at one point, what if we did not find the value, right? So what happens then is that at one point the low will be higher than the high, right? So if this is the low and this is the high, at one point the low variable, the low boundary will be higher than the high because of the fact that like it's going through every single thing. And if it doesn't find it, then at one point the low will be greater than the high. Then it will end, right? Because while loops are saying as long as this condition is true, then we will continue running. But yeah, this condition is kind of just saying like in case it does not find it, the value we're looking for. Then kind of like expected, we're setting a mid value. We're saying low plus high divided by 2, which is again finding the average of the two values of the two boundaries. We're saying if ARR mid equals to value, then we already found it, right? We don't need to check it again. So we said found equals true because we found the value. And then we automatically break the loop because we don't need to go through the rest of the loop anymore. Otherwise, we're saying, okay, well, if the middle value of the array, if it's greater than the value that we're looking for, then we're setting high equal to mid minus 1. Because of the fact that, okay, well, if the middle value is already greater than the value, then we don't need to search for anything higher than the middle at all. So we X out all of that and we just move the boundaries to mid minus 1. The reason why we're not considering the high anymore is because we already checked it here, right? Like we already checked whether or not the middle value is equal to the value here, and it's not. So we don't need to consider the middle again. So that's why it's mid minus 1. So again, that's kind of like the halving part. Then we're doing low, otherwise low is equal to mid plus 1. Because like if the middle value is not equal to the value, if the middle value is not greater than the value, then it must be lower than the value, right? Like it must be less than the value. So what happens then is we set the low boundary to mid plus 1 now, the other way, right? Because if the middle value is already less than the value, then we don't want to consider anything below that, right? Because we don't need to consider that anymore. So we readjust the lower boundary to make it so that it's mid plus 1 now. And lastly, we just print out found, like if we found it or not. And that will just return a true or false. And it works. And I feel like if I just talked about the explanations behind it and I showed you the guessing game and I showed you the visualization tool, I feel like you guys would be able to accomplish this. Like you guys would be able to figure it out. It might take a bit, but I feel like you guys would be able to figure it out. Meanwhile, over here, recursion, yeah, it might be a bit more complicated. So with this, right, we still have the array with our values. Then you can see we have two static methods. So the first one over here, let's do it piece by piece. We're saying return a Boolean because we want to know if the value is found or not. We're saying binary search, and then we want the user to pass in an array for us to search through and a value that they want to find. What happens here is that you see that I'm calling binary search again, but I'm saying ARR, I'm passing in ARR, I'm passing the value, I'm passing in a 0, and I'm passing in an ARR.length minus 1. The question is here, is this binary search ARR value 0, ARR.length minus 1? Is this command calling the first binary search method, or is it calling the second one? So just give me a 1 or 2 in the chat. So take a look at the amount of parameters here. What have it's kind of far back, but what have I said? Like, how do you differentiate between two methods that have the same name? Any guesses? Take a guess. Either way, just take a guess, 1 or 2. Yeah, Jeffy's right. So it's gonna run number 2. The reason for that, again, like way back when I talked about when you have 2 methods of the same name, even when that happens, you can always differentiate which method you're calling by the amount of parameters that are there. So in this case, you can see this one only has 2 parameters. This one has 4. Well, the fact is that there's 4 here, so that means that we're automatically going to be calling the second one because of the fact that there are 4 parameters. So anyways, that was kind of a pop quiz. Besides that, will you notice here that I'm saying private? And I'll explain that a bit more later. But otherwise, like, it's pretty much the same. You have the same return type, you have the same binary search part. But this one time, we're just adding an int low and an int high, just so that we can like continuously like adjust what the boundaries are. This should be familiar. We're just finding the middle value. This should also be familiar because we're just seeing if the middle value is equal to the value that we want to find. If it is, then we just return true. We're done, right? So, and then this should also be relatively, actually no, this is kind of new, but essentially what it's saying is if low is greater than high, that means we return false, because like that means the array just went through, the search just went through all of the array and it did not find anything. So this is a kind of like a base case, right? This is a base case. This is also a base case. The ARR mid equals value. These are base cases for if anything happens. And in this case, if low is greater than high, then we just return false because it didn't find anything. Meanwhile, again, we're just comparing the values then, right? We're just saying, okay, well, if ARR mid is greater than the value, then we don't want to consider anything above that mid value. So what happens is that this is where the recursion part comes in. We call binary search again, and because there's 4 parameters, then we're calling this one right here. And then we're saying ARR value, those are still the same. But now this is where it changes, right? So this is how we're gonna slowly readjust using recursion, right? We're saying low still, because like it's still gonna be the same. But now we're saying mid -1 to replace the high value, because now we don't want to consider anything above the mid value anymore. So that's why we're setting the new high value to be mid -1. Otherwise, we're saying else, since that means that the middle value should be less than the actual value. Then we just return binary search. The array of value are still the same. We're saying mid +1 now, because that means that we should not be considering anything less than the middle value. And we're saying high. So we're only considering that. So slowly, that is how we readjust. Yeah. And here you can just see this. Now, pop quiz, what is this going to be calling? What is that particular method call going to be calling? The first binary search method or the second one? So 1 or 2? Yeah, it is 1. So again, how you tell this apart is because of the amount of parameters. But this matters, right? Because like, why are we just calling this one, right? Like, why aren't we just calling this one, all right? The one with 4 parameters. Well, the thing with that is that you can see that when you're using a lot of different methods, so for example, you're using the math.pow method, right? The one that can help you get exponents. If you're using that method, which is one that was already built by Java, then you don't have to worry about it as much, right? You only have to worry about putting in the right base that you want to use, and you want to put in the right exponent, right? Those are the only 2 things you have to enter. But the thing is, always, when you're first using this binary search method, you're always going to want pretty much to have your low value start out at 0 and your high value to start out at array.length -1. But like that's tedious to the user, right? Like they don't need to have to enter that every single time, right? Like that's not something they should know, because by then they'll be wondering, okay, why do we need to enter 0 and array.length -1 here, right? So the point is to make it so that the user only has to enter the stuff that they need to in order for the binary search to take the work and do its thing, right? So by just eliminating that and only having 2 parameters that the user needs to enter, that makes things a lot easier and a lot more like not as complex for the user to understand. So by now, if we just look at this, right, if I didn't program the binary search, I'm just looking at this, I'm just like, okay, well, I just have to enter the array that I want to use as well as the value that I want to find. Okay, easy peasy, right? Like that's what we should be doing. And it's a lot easier that way for the user. But yeah, this is kind of what we call a helper method. This one right here, I think it's called a helper method. Yeah, but essentially it's just doing one job, which is kind of making things a lot easier for the user to understand. So by the user calling this first method, then we're able to automatically pass in those values into the other one and automatically set for each time that the user calls it that the low is 0 and the high is array.length -1. And yeah, the reason why I made it private here was because the user's never really going to call this method anyways from like the class, right? It's never going to call it from the public class, so, or like any other class in general. So therefore, we only need to make it private because like only this, oh, never mind. Well, anyways, let's say that another class, that you created another class and you wanted to call this binary search method. Well, then you don't have to worry about this, and you know, it's not a big deal then because of the fact that you're only supposed to be calling this binary search one, the first one. So I kind of just made it private to reduce the amount of complexity. But yeah, that's kind of like how you can start using public and private to like change things around. All right, that is the end of the lesson. All right. Unfortunately, I don't think we're gonna get to class problems today. Oops. But yeah, I hope it sort of makes sense, and if not, you can go check out the visualization tool that also has the code here. If you like look at this, it's in Python though. This is not Python. Well, it's not Java, so yeah, it might be a bit different, but yeah, it's the same code essentially though. Like the logic's still the same. Right.